So we have b here, which is z squared minus 2 into bracket cos beta times z plus 1 equal to 0, where beta is a member of real number. So we're going to find the value of z. When you compare with a z squared plus bz plus c equal to 0, you see our a equal to coefficient of z squared is 1. Coefficient of z here is negative 2 cos beta. Our constant c equal to 1? To 1. So now, from the quadratic formula, which is z equal to negative b plus or minus b squared minus 4ac divided by 2a. So it means that our z is negative. Negative, negative becomes positive. Plus or minus square root of b squared. That is negative 2 cos beta squared minus 4ac. Minus 4 into bracket. Our a is 1 and also c is 1. 1, 1. Divided by 2a. 2 times the value of a, which is 1. So therefore, z is 2 cos beta plus or minus negative 2 squared, that is 4. 4 cos squared beta. Then minus 4 times 1, that is minus 4. Divided by 2. So where z is 2 cos beta plus or minus, let us take this 4 out of the bracket. So that is 4 into bracket cos squared beta minus 1. So divide by 2. Okay, you remember what is the value of cos squared beta minus 1? Remember, from when you have cos squared beta plus sine squared beta equal to what? To 1. I think remember this one in trigonometry. So what is the value? I need cos squared beta minus 1. So I'm going to bring this one here, and I take sine squared on this side. So that is cos squared beta minus this one. So when I take sine squared on the right hand side, it will change the sign to become what? A negative. So you see the value of cos squared beta minus 1 equal to negative sine squared beta. So which means that our z will be equal to 2 cos beta plus or minus square root of 4 into bracket. The value of cos squared beta minus 1 is negative sine squared beta. Then divided by 2. So our z is 2 cos beta plus or minus root negative 4 sine squared beta. Divided by 2. So remember, we are under complex number. Negative 1 is I squared. So this will be 2 cos beta plus or minus root 4i squared sine squared beta divided by 2. So our z is 2 cos beta plus or minus, what is root 4? 2. What is root I squared? I. What is root sine squared? Sine. That is 2i sine beta divided by 2. So if we divide by 2, z1 will be 2 divided by 2 cos beta plus 2 divided by 2, 1 I sine beta Then Z2, it will take a negative. So which is cos beta minus I sine beta. So now our set contains two values, which are cos beta minus I sine beta, then cos beta plus I sine beta. So those are the values of Z. Any question here? Do you have any question? Yeah, I think each step, it is very clear. So let us go to other examples. Number 2 on quadratic equations. I'm going to see how you can solve quadratic equations. This is number 2. Find the quadratic equation with a real coefficient given that -1/2 plus √3/2i is one of the roots. So in a complex number, when you're given one of the roots, remember when a quadratic equation which is in the form of az plus bz plus equal to 0, it has two roots. It has two roots, which is z1 and z2. Those two roots, when you take z1 plus z2, when you add them, you have to get sum s. This s means sum. So when you take z1 times z2, you get p. And this p is product. So it means that when you are given one of the roots in a complex number, then another root is the conjugate of that one. So, but when you take that z1 plus z2, it is a sum. And when you take the product of those roots, you get product. So there is a quadratic equation which is in a form of sum and product, and that is z squared minus sz plus p equal to 0. So this is a quadratic equation in a form of sum and product. So if it is z squared minus sz plus p, so s is sum, p is product. And to get s, which is the sum, we just add two real roots. We add two roots. And to get product, we multiply what? The roots of that complex number. So then, our z1 is one of the given roots. One of the roots, which is -½ plus √3/2i. -1/2 plus √3/2i. So meaning that the second root is the conjugate of this one. So which is -1/2 minus √3/2i. So now, how are we going to form a quadratic equation? Addition of them is sum. We're going to take z1 plus z2 in order to get sum. So now, this is sum. So our sum will be equal to -½ plus √3/2i plus -½ minus √3/2i. So which means that is -½ plus √3/2i minus ½ minus i√3/2. So this one goes with that one. -½ minus ½, that is -1. So our sum is -1. Product. Our product is z1 times z2. So the answer is -1/2 plus √3/2i into bracket minus 1/2, then minus √3/2i. So our product is -½ times -½, that is 1/4. -½ times -√3/2, That's positive root 3 over 2i. Root 3 over 2i times negative half. Negative half times negative half, that is 1 over 4. Negative half times negative root 3 over 2, that is positive root 3 over 4. Because it is negative, negative comes positive. 2 times 2, that is 4. Then, root 3i times negative, that's negative, root 3 over 4i. So then, root 3 over 2i times negative root 3 over 2i. That is negative 3 over 4i squared. Because root 3 times root 3, that is 3. So our p is 1 over 4. This goes with that one. I squared, it is negative 1. Negative 1, that is positive 3 over 4. So the answer is 4 over 4, which is 1. So our p also is 1. So now from z squared minus sz plus p equal to 0. So our z now, our quadratic equation will be z squared because sum is negative 1. Negative, negative comes positive. Then our p, which is product, is 1. So this is the required quadratic equation. That is required. That is required. This is required quadratic equation. It is a required quadratic what? Equation. So that's how we do it when we are given one of the roots. The second root will be the conjugate of the given one. I think this one is clear. So let's go to number 3.